طور سينين وهذا البلد الأمين لقد خلقنا الإنسان في أحسن تقويم ثم رددناه أسفل سافلين إلا الذين آمنوا وعملوا الصالحات إلا الذين آمنوا وعملوا الصالحات فلهم أجر غير ممنون فما يكذبك بعد بالدين أليس الله بأحكم الحاكمين صدق الله العظيم.
Jazakallah. As you all know, today's webinar is all about ETABS, which is going to be introduced to you all through the platform of ASCE Quest Chapter. I hope most of you probably would know what ASCE is all about, but still, let me give a brief overview. ASCE stands for American Society of Civil Engineers, which stand at forefront of a profession that plans, designs, constructs, and operates society's economic and social engine. Currently, we have 3 official chapters of ASCE in Pakistan. Fourth one is in progress, that is none else than ASCE Quest Chapter, as its international registration is in process. Before going further, I would like to invite our dedicated and hardworking president, Mr. Kamran Ahmed Rin, to speak something about today's webinar. Mr. Kamran?
Assalamu alaikum. Am I audible? Let me know. Am I audible? Larit?
Yes, you are audible.
Ji Kamran, you are.
Thank you so much for your appreciations. First of all, glory be to Allah, who is veiled by the attribute of his appearance and is concealed by the satin of his light, who created the things from non-existence and created the heaven and earth and administrated all the world between them. Amen. Most respecting chief guest, Professor Dr. Abdullah Sant, the Pro-Vice Chancellor of Quest Nawabshah, and currently also he's with us as a chief advisor of ASCE Quest Chapter. Secondly, I would thanks to Engineer Sir Arif Asghar Gopang Saab, who has really supported us and working with us as a faculty advisor of ASCE Quest Chapter, and currently he is also the voting grade member of ASCE International. After that, I would thanks to Engineer Mohsin Ali and Miss Madiha Aslam Sumro, who are serving as a practitioner advisors of ASCE Quest Chapter, and they are also the voting grade member of ASCE Quest Chapter. I would really thanks to our today's instructor of the webinar, Sir Rabinder Kumar. Thank you so much, sir, for giving us your precious time for this webinar. And secondly, really, I would thanks to Professor Dr. Taha, who also thanks and who also appreciated me for this, the Pro-Vice Chancellor of Mehran University of Engineering, Science and Technology. When I contacted with Sir Rabinder Kumar, he appreciated all the efforts of ASCE Quest Chapter and Civil Engineering Department. And of course, no doubt he appreciated all the efforts of my mentor, most respecting Professor Dr. Abdullah Sant and Engineer Sir Arif Gopang Saab. about their hardworking efforts on behalf of the Civil Engineering Department, Quest Nawabshah. As you know that Civil Engineering Department is one of the most oldest department of this civil engineering point of view. Department, our oldest department in Quest Nawabshah. ASCE Quest Chapter, this VN which was taken by our team, and no doubt this initiative was this idea was all about my mentor, most respecting chief advisor of ASCE Quest Chapter, Dr. Abdullah San. He always asked me that you should work for that. So it was my wish that to open this chapter for our department, and Alhamdulillah, now we are representing this ASCE Quest Chapter at national level and also Alhamdulillah at international level. Recently, I was in contact with ASCE chapter of RV College, India. They were appreciating the efforts of ASCE Quest Chapter, and they said recently they invited me. They said that in January or December, we are going to arrange a mega event, and we will really be honored that your team ASCE Quest Chapter should participate there. And it's all about the cooperation of our advisors, practitioner advisors, and faculty advisor, and the most respecting Sir Abdullah San. ASCE Quest Chapter, its main objective is to provide the technical activities and also the social activities on behalf of the civil engineering department to the students of Quest, and especially to the students of civil engineering department. And Alhamdulillah, I know that day when we inaugurated this ASCE Quest Chapter with the hard work of this team. And really, I would never say that just 1 to 2 members have worked hard. And Alhamdulillah, we with the team of 75 members, Alhamdulillah, we are representing our ASCE Quest Chapter at national and international level. And I hope this is a ASCE Quest Chapter in whole year has worked really hard under the leadership of Professor Dr. Abdullah San and Sir Arif Gopal Saab. And this is the last webinar of our last event of this tenure. We had wished that we should arrange that events which we had already planned for university, but due to scenario of COVID-19, we unfortunately couldn't do arrange such kind of activities. But Alhamdulillah, whatever we can do, we did it with the cooperation of our advisors. And Alhamdulillah, this tenure is going to finally at the end. And inshallah, now there will be the new leaders or members of ASCE Quest Chapter. And I would really appreciate all the members of ASCE Quest Chapter that who are always working hard. And again, I would thanks to Professor Dr. Abdullah San for their outstanding hard work for ASCE Quest Chapter opening this chapter, first number in Sindh and fourth one in Pakistan. And Sir Arif Gopal, who has no doubt when we are at home after COVID-19, Alhamdulillah, regularly Sir ask us and discuss with the activities regarding the ASCE Quest Chapter 2 days early.
Firstly, I would like to welcome Practitioner Advisor and Affiliate Voting Member of ASCE, Engineer Mohsin Ali, who is currently serving as a Junior Civil Engineer at Cornerstone Consultant and Associate at Private Limited. Sir, please speak something.
Hello and Assalamu alaikum everyone. Please give me a green signal. Are you listening me?
Sir, please close your microphone, please, so that all should be the audible.
Okay.
Lara, you should continue our event.
Kamran, just a minute. I have a net issue. Give me 5 minutes. I'm joining you.
जी जी मैम.
Nari, if you can continue with the other sessions, please.
Ji, I think there is some sort of connectivity issue with Engineer Mohsen Ali and with Ma'am.
जी, Lara, are you getting me? Sir Mohsen has that said that I have got internet problem. You should continue the second guest, Ma'am Madhiya.
Ma'am Madhiya said she needs 5 minutes.
Okay.
Kamran, can you continue with someone first? I will join you after that. As I
जी,
said,
जी.
you know, I have an internet issue. I am sorting that. As soon as I get back to you, I will continue.
जी 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 मैडम. Thank you.
Okay, Kamran, should I continue then?
जी जी.
Okay. Now it's time to invite Faculty Advisor of ASCE Quest Chapter, one of the most dedicated and sincere advisor of Team ASCE, Engineer Arif Askar Gopang, who absolutely needs no introduction when it comes to Quest, but for others, let me give his brief introduction. Sir is currently serving as a lecturer at Civil Engineering Department, Quest Nawabshah. We are all glad to have him in today's webinar. So please speak few words about today's webinar.
Am I audible to you all?
Yes, sir.
Yes, sir.
The Honorable Pro Vice Chancellor Dr. Abdullah San sir and respected guest speaker Sir Rabinder Kumar sir and the respected advisors of American Society of Civil Engineers Quest Chapter, Madam Madhiya Sumru, and the Mr. Mohsen Ali sir, and the respected participants. I welcome you all to this wonderful webinar about ETABS. I'm very happy to be part of this proud ASCE Quest Chapter, and I really appreciate the efforts of proud team of American Society of Civil Engineers Quest Chapter. This chapter is striving hard for building the capacity of graduates and the civil engineers by making them familiar about the important topics and the various softwares used in civil engineering. So I will not take much time, and I would like to listen to our guest speaker. Thank you.
Professor Dr. Abdullah San, Pro Vice Chancellor of Quest Nawabshah and Chief Advisor of ASCE Quest Chapter, who has always been a great mentor as he inspired us to take the world to a whole new level in respect of civil technology. Really an honor to have him in today's webinar. So please speak few words.
Thank you, Beta. It is really nice to be with you all. And first of all, I would like to appreciate the efforts of Kamran and his team. In fact, we have done nothing with ASC, but it is all the efforts of Kamran and his team that they have just worked on the track which we just told them. Otherwise, all the efforts are there, and I really appreciate them. They have also arranged the other webinars before today's webinar, and they were also very successful. And I'm really confident that also today's webinar will be very helpful, and Engineer Rabinder Kumar will deliver his expertise to the participants regarding ETABS. For civil engineers, ETABS is, as I've been telling you in the classrooms, those who are my students, that the softwares nowadays for civil engineers it is really mandatory to learn. Without software engineer, civil engineer is nothing, means he does not have any skills. He may have the knowledge, but for skills, he has to learn the software. Now, manual design is almost very rare. And all the consultants, all the designers, they are using the number of softwares. And among those number of softwares, ETABS is most important and being used widely all around the world for the analysis of the building systems, in fact. And this is three-dimensional software. This is very useful software. I also have used that software. And also other softwares you may learn. With ETABS, the civil engineer must know AutoCAD. That is very essential, basic software for civil engineer, because the drawing is the language of engineers. That drawing may be manual or that drawing may be with any software. And other softwares like the Strat Pro, the other softwares which are being used for the design of the structural systems, or maybe other softwares which suppose I'm not interested in the building systems, then I have to go for the options to learn the other softwares which may be used in the rigid pavement design, or maybe in other areas. So those softwares are important to learn. But it is not only to attend the webinar and to listen the engineer Rabinder Kumar and to look at his presentations, or just to print or save that presentation. It is not enough. That is important that after this webinar, all the participants must in fact do some practice on ETABS. They must do some working on ETABS. And the participants may follow the whatever guideline be given by the speaker today. In addition to that, I must also advise that any software, now whatever software may be, if you are interested, you can learn yourself even. Because all these softwares now are window-based software. They have this GUI system where the also helpline on the top menu bar is there. If you just print that help file, complete help file, and if you go through that help file, get a highlighter and highlight the important things, and you may find very simple example in the start. If you start with simple example, then you will lead to the bit complicated problem there. Ultimately, when you will finish that help file, you will be really able to use that software. I myself being the student in 81 batch. 81 batch means in 82 we were in class. At that time, there was no any software. In fact, there was no any software to use for the design analysis or for any other area of the civil engineering. We were not taught those softwares, and we were even not able to access the computers, because at that time very few computers were in the universities, and they were just the for symbols. They were just for the showpiece. We were unable to access even. We were unable to work on those computers. But now, after at the age of 34 year experience in teaching and research, I myself am confident to use the ETABS, the Strat Pro, and all other softwares which are being used in the design analysis, particularly in the area of building system, because I am related to RCC and concrete, so in the building and other infrastructure which are related to reinforced concrete, I am able to use. That is why I have not learned the software through any organization, but all these softwares I learned myself. So this is just a guideline for you that it is not difficult to learn nowadays any software. If you are willing to learn, you can learn yourself really. So I am confident that today's presentation by Rabinder Kumar will be definitely successful for you, will be helpful for you. And I also welcome the Rabinder Kumar, and I also would like to say thanks to him that today he is here with the participants to deliver the presentation on the ETABS. I'm also thankful to Madhya and the Mohsen Ali, who really cooperated with my team to get the further process of the ASCE chapter approval through the ASCE. So good luck, and I hope that in future you will have also such webinars and seminars that may be physical. Thank you very much.
Thank you so much, sir. Thank you so much, sir, for giving us your time. It was great to hear you. Now it's time to call Engineer Madhiha Aslam Sumro, another practitioner, advisor, and member of ASCE. She is currently working as a principal engineer at Water Division, Engineering Management Consultant, EMC, Pakistan. She has overall experience of 16 years in infrastructure and master planning projects, including wet utilities and hydrology. Now, I would like to invite ma'am to speak something about today's webinar.
Assalamu alaikum. Assalamu alaikum all. And sorry for the late and disturbance. Actually, I am on site visit, and just on a request of Kamran, I stopped at a restaurant and joining you all. And first of all, I thank Sir Sand Abdullah Sansa. He's really a role model teacher for us, and he always have a confidence on me. And with his support, really, I am at any place at the moment. I'm just because of teachers like Sir. Actually, I thanks to all of you have a confidence on me and make me your practitioner advisor. And I thanks a lot Sir Arif. He helped me a lot in this process, and Kamran for motivating me to join this. Anyway, it is a great platform for our young engineers to search their opportunities and have a extracurriculars in their life. As I'm a practitioner in this field, and I'm facing a lot of things at the time when we were in studies, we have a limited opportunities for this type of circle. We don't have any social links to connect to the professional nationally or internationally. But we tried hard to join these type of networks. But if you have an option to join these type of networks, it is a great opportunity. And I'm here to guide you all that what you have to do in your future, what you have to decide for your future, and what you have to do for your field, in whichever field you are. Actually, I started my career as a civil engineer. I'm from 2K Beach, Kaidewam, University of Science and Technology, Nawabshah, Quest. And I'm a civil engineer. And I done my BE in 2004. After that, in 2005, January, I joined Umar Munshi Associate as a design engineer, where I started my career and in infra. Wet utilities, major part is the wet utilities. As I'm a designer of water supply schemes, sewerage schemes, hydrology, drainage system. And after that, I joined Usmani and Company and served 14 years in Usmani and Company. After that, I now in July, I joined this engineering management consultant company. Here I'm in my 16 years of career. I designed a lot of master planning projects, including DHA City, which is a major landmark and well known to all of you, and Phase 8 in LDA City, Lahore, and now I'm designing and master planning Turbat City. As I always discuss with Kamran about the career opportunities, he's doing very good thing by doing these type of webinars and these type of certifications. This will help you a lot in your practical field. As nowadays, PEC also make a rule like that if you are having a 5-year experience, after that, if you're going to apply for a professional engineer, then you have to submit some CBD points. And how you can get these CBD points? From these type of webinars, from these type of certification courses, from seminars. So these are the best activities you have to do for betterment of your practical career. And actually, I am on my site visit. That's why I really don't know what else I have to tell you, but I think it's enough from my side. So anyone other can join, please, as I am also, my mind is diverted. If any have a question, ask me, I will answer you, but I was really not prepared for this meeting. So I don't know, I didn't write anything. So I'm sorry if I'm not telling you anything which you are expecting. So sorry for that.
Thank you so much, ma'am, for giving us your precious time. We'd also like to thank Mr. Arif Askar Gopang, Sir Mohsen Ali, who was not able to join us today because of some connectivity issue. But although he tried, thank you so much, sir, for that too. And also Professor Dr. Abdullah San, Vice Chancellor of Quest Nawabshah. Thank you so much, sir, for giving us your time.
Okay, so I welcome you formally all in the introductory webinar of ETABS. So my name is Rabinder Kumar. Before I will just give you the brief introduction of mine. I graduated from Mehran University in 2013. In 2017, I completed my master's from University Technology Petronas, Malaysia. And right after completing my master's, I joined the Ghulam Isa Khan Institute, the GIK Institute, and I served there for 2 years as a lecturer. And after that, after serving my services for 2 years, I joined Mehran University Department of Civil Engineering, and I'm also working as a lecturer here. Civil engineering is my field of study and field of my interest since last 10 years, almost 9 to 10 years. I always motivate my students to improve their soft skills, because number of students come when I teach them the subject. I mostly prefer to teach strength of materials, theory of structural analysis. So many of my students claim that whatever we are studying in the classes, they are not being used in the real field. But actually, this is we are not being taught with the application. So in this seminar, through the slides, you will be able to understand what things we will be covering in this seminar. So quickly, we will be understanding the architectural layout. After that, how to decide the sizes of columns. Okay, for 2 to 3 storied buildings, for high-rise buildings, for the beams having larger spans. And after that, we will be discussing about the orientation and position of the column, how to locate the position of column in the building plan. And finally, we will switch over to the ETABS, and I will tell you how to model a structure and how to interpret the analysis results and design building, which is also being practically designed in the design offices. It's not all theory. I will give you the reasoning why we do this. If I select a parameter, I will tell you from which code book we are using. Engineers will decide the location and position of the column. So how to insert the column sizes in the building plan? So this requires a logical judgment. So there are not written rules. This is based on your experience, logical judgment, and the practice. And you can also see the construction around your areas, or if you just take help from the plans, which are already plans of the already constructed buildings. So this is how you will get how to do this kind of arrangement in the structure. So after deciding the position of it, after inserting the columns at the corner of the building, so I will show you some thumb rules. So regarding the sizes of columns, so I have categorized it in 3 cases. Okay. So number 1 case is which this will tell us about the 2 to 3 storied buildings, and second case will tell us about above 3-story buildings having larger spans. When I say larger spans, that means more than 15 to 16 feet. In third case, we'll discuss about the high-rise buildings. So let's discuss about the case 1, which is regarding 2 to 3-story buildings. You can also observe in a house which you are living, it should be 2 to 3-story, and you will see the column sizes. It will follow this criteria. So you start your analysis. Now the architect gave you this plan. If the wall size is 6 inch, so mostly what engineers do in order to hide the column in the wall, so they choose the smaller dimension is 6 inch, and the longer dimension, it varies from 15 inches to 18 inches. But British code says that in any case, the area of column should not be less than 108 inches square. So when it is 108 inches square, so that means either you choose 6 by 18 or 9 by 12. So this will comes out to be 108 inches square. But Indian codes tells the minimum size of column is 9 inch by 9 inch. So American code does not specify any sizes regarding the column. It's based on the designer, which column size he wants to give in the architectural plan. So as in our case, the exterior walls are of 9 inches. So that is why you can see the smaller dimension of the column is kept as 9 inch and the longer dimension is kept as 12 inches. So you can start your analysis with these sizes of the columns. You can take the screenshot. I will ask organizer to email these slides to everyone, the participants of today's session. So start with a 6 by 18 inches. If the building is failing at this column, increase the size to 9 inch by 12 inches, 9 inch by 18 inches, or 9 inch by 24 inches, depending upon the number of stories, you can increase the sizes. And in ETABS, there is an option. You can define all these sizes, and you just on ETABS now choose the best one from the given design. Okay, there is an option. I will just give you the introduction how to access that option. You just write down all the sizes which you want, which you think these sizes should be in your building plan, or these sizes should be located in order to pass the structure. So you just give these sizes to the ETABS and just instruct the ETABS that I want these sizes in my plan. So ETABS will design accordingly. So these sizes are safe for the span length of 16 feet or 5 meters. That means our master bedroom in the residential building is of around 16 feet by 14 feet. So you can use these sizes of columns with this span length. That means you don't have to put any intermediate column, because whenever you design a mosque or whenever you want to design a hall, so in such structures, it is not recommended to give an intermediate column in between the structure. So we just want a clear span, just like warehouses, we just want a clear span. So in such cases, we need to play with the beam sizes and the column orientation. So for case 2, if you are designing above 3 stories buildings having larger spans, so choose these sizes of the column, 12 inches by 12 inches. If you are working in metric system of units, so 3 or 5 millimeters, or you can go with 12 inch by 18 inches or 9 inches by 24 inches. So here I would like to add something. I recommend this size of column, 6 inch by 18 inches, because this will surely pass your building in a gravity loading. But if you are designing your structure for lateral loads or seismic loads, majority of the column will fail. Majority of the column will fail if you give the 6 inch by 18 inches. So in such cases, go with the 9 inch by 12 inches size. And you must remember that civil engineering is all about imagination, assumptions, and logical reasoning. So every time, even in our bachelor classes, whenever we solve a derivation, we assume the things. If the assumption is failed, so we again assume the things till our requirement is achieved. So similar is the case with the design process. First you assume, so it is an iterative process. First you assume the things, then check the things. If it is failing, then you increase the things, check the things. If it is again failing, so you keep on increasing the process until you get the successful or safe design. For high-rise buildings, it should not be less than 216 inches square. So that means 18 by 18 inches column used. Increase the size of, if the column is failing under this dimension, so what you do, just increase the width and length of the column by 6 inches, and again analyze your structure whether it is falling that passing that dimension or not. If it is not passing, so keep on increasing the dimension of the column, and ultimately you will get the safe design. Or in order to avoid this iterative process from where you can download many things. So observation is very important in designing. So that is why I told you manual calculation gives you the feel. Okay, so that means when have you the feel, so you will be able to figure out whether the things are going in the right manner or not. Regarding the beam size, so it should not be less than 9 inches by 12 inches, because we know that the beams and slabs are casted monolithically. So 6 inches will be in the slab and rest of the 12 inches, yes. So 6 inches will be in the slabs and the rest of the 6 inches will be in the part of the wall. Now this is about the sizes. So once you decide the size of the column, so now what we have to do, now we have to locate the columns in the building plan. In order to locate the column, so what we have to do, first we try to fill the corners. So whenever you see a beam column junction, so you will see the beam column junction, so you will just paste the column. You put a column over there. Don't worry if you are putting the number of columns, because that's how you will learn. Because sometimes if you're new, you will try to put a column here. But when I see this span is just 7 feet, so we don't need any column. So that is why it's just based on your experience of where to put the columns, where not to put the columns. But the thumb rule is, if you try to fill at the corners of the building. So whenever you design a staircase, do not forget to place the columns at each corner of the staircase, because we know that the staircase experience higher axial loads and lateral loads. So always try to put the columns at each corner of the staircase. So whenever you see a beam column junction, so this is a beam, this is a column. So whenever you see a beam column junction, just put the column here. Larger spans to reduce the bending moment in beams, because in our design process, moments are the deciding parameter for the steel calculation. If the spans are larger, so it will create the larger moments. So if the moments are larger, the area steel will be more. So if the area steel is more, that means it will give you the uneconomical design. So we have to look for the safety. We have to also look for the economy whenever you design a building. So these are certain rules. You can start your planning and modeling analysis software. So first, architect gives you the plan, and accordingly civil engineer decides the position and location of the columns and also the sizes of the columns. So basically these are based on assumptions. So when we put this assume in a structural engineering software and we will design, so software will tell us that whether our assumption is correct or not, and what changes we have to make based on the results given by the software. So we will move accordingly. Now, in order to model, once you decide the position, location, and the sizes of the columns, now what we have to do, we need to bring that model in an ETABS software. In order to bring that model, in order to model, analyze, and design a building in the ETABS, we need to follow these 10 steps. So these 10 steps are very important, and majority of the things we have covered in our theoretical classes and our bachelor's or master's. First, we have to decide the grid system or story data. The grid system basically tells us, now look at this slide. Okay. Now look at this slide. The grid system will tell us that what is the distance between the two columns. So it's a distance from center to center of one column to the center of another column. So this is very important to model in the ETABS. So otherwise it will be very difficult to model the structure without having the reference line. So grid lines basically acts as a reference line. So these are the distances between one column to another column. So in this section, in this plan, you will see that central line of beam and central line of column is coinciding. But actually this is not the case in real field. Sometimes the center of column is away from the center of beam. In such cases, what we do, we will model the rigid joints. So I will just give you the introduction how to model the rigid joints in this session, but I will just keep things simple in order to develop your interest in learning the software, because if I tell you the complex things, it will not motivate you to practice after the session is finished. So assign the grid system. So this means the central line. And the similar things we do when we try to execute that plan on the site for the construction. We always give the markings, this demarcation, we name it as a demarcation. So this is basically the grid lines. We try to, the same grid lines we model in the software and the same grid lines we model when we try to execute the structure or when we try to execute the construction of that structure. After that, material properties are very important. Which type of material you are going to use in your building system, whether it is an RCC frame structure, whether you are going to design a steel structure, whether you are going to design wood structure. So how the software will know that which type of material you are using. In order to tell the software that I'm using concrete, so what parameters do I have to give to the software? Number one is compressive strength. The compressive strength is not the only parameter. You have to give the more information. So, and second information is modulus of elasticity. Sometimes the Poisson's ratio is also given to the software. So depending upon this data, the software will decide that I am dealing with the concrete. If you are designing with the designing a wood structure, so what you do accordingly, you have to give this parameter: the compressive strength of that material, the modulus of elasticity of that material, and the Poisson's ratio. And these all things we have covered in our theory classes. That is why I'm just repeating, connecting the theory classes with this webinar. So we've discussed all these things in the class. Now we will be using, because these things are very important in our design. After that, we will define a section. Defining a section, that means we will give the dimensions. What is the dimension of the column? What is the dimension of the beams? What is the material of that column? So I just gave you some thumb rules, some assumptions regarding the sizes of columns and beams. So we will be using that sizes in our design. Assigning section. So once you define any section, now you have to, what you have to do, you have to assign that section on that grid point. For example, so this section is defined. Now we have to assign that section, assign this section at this location. So step by step, I will tell you how to do this. After that, assigning frame and shell loads. So using this ASCE, minimum design loads and associated criteria for buildings and other structures. So we will be using this code book, and from this book, depending upon the nature of a structure or the type of structure, the appropriate word should be the type of structure. That means whether we are going to design a school building, hospital, institutional buildings, courtrooms, central jails. So the code book decides what type of live loads and dead loads you have to use depending upon the type of structure. So I will, sole purpose of this session is to tell you guys how to use the information from the code books. Because in our theory classes, we just assume a beam which is having a 20 pound per foot square of uniformly distributed loading, something like that. We just assume that things. I will tell you how in actual these values come from. Assigning seismic and wind loads. At the start of my presentation, I just gave you some introduction how to decide the zones, zone vectors. So again, I will be using uniform building codes, because Pakistan building codes and uniform building codes are compatible to each other. Almost the data is same. So for this seismic design, so we'll be using the data will be taken from Pakistan building codes, but since the ETABS in ETABS software there is no option to option regarding the Pakistan building codes, so we will be selecting the uniform building codes in order to punch in the data. After that, we will select the defined load combinations. Defined load combinations are very important because this will decide at what critical load your section is failing, or at what critical load your section is experiencing the maximum loads. When I say critical load, so that means combination means the combination of dead loads, live loads, lateral loads. So, and finally the analysis chips in. We'll just a single button and it will give us the analysis. The important part is to read the analysis, whether the analysis is going fine or not, how to interpret the results. So we must have the basic concept about the moment diagram, shear force diagram, axial diagram, and some deformation regarding the deformation. So in this way, we will be able to figure out about whether our model is working perfectly fine or not. And after that design, obviously we will not design the things manually. If you want to design, you just take analysis results from the ETABS and follow any book, structural design book, concrete design book. So all the design procedures are written there. Form an Excel sheet, as I just showed you about the footing, which is the sheet I designed. So if you can also design your sections manually, because some structural firms are also doing in this way. They are using the software only for the analysis and they are doing the things manually for the design. And finally, detailing. So design means it will give us how much steel reinforcement is required in order to bear the load which is coming from the top. So in detailing, we will try to make the reinforcement plans, how much reinforcement, the section of the beams, section of the columns, the percentage of reinforcement is shown in the detailing. So now I will switch to the ETABS. So in my PC, I have both ETABS 2016 and ETABS 2018. But in ETABS 2018, so you won't find UBC code. So that is why I'm using ETABS 2016, because in ETABS 2018, everything is integrated with the ASCE codes. So, but regarding the seismic data, which is given to us by Pakistan building code, so the parameters are hard to find. So that is why I will just stick to ETABS 2016 for the design. Rest of the procedure is same. And one more thing, in ETABS 2016, you will get the detailing option. Detailing options mean with a single click, the software will generate all the drawings for you, all the beam column plans, layouts, reinforcement calculations. But in ETABS 2018, this feature is eliminated. So you have to download CSI detailing software in order to do the detailing for your structure. So this is the interface of the ETABS software. Regarding the installation, you can go to the CSI website, because this software is designed by CSI, Computer Structure Incorporation. You can select the trial version, or you can also download this software from downloading websites. And we know that the famous is torrent, which is mother of all the downloads. Or even you just write the ETABS and with the version on a Google, so it will give you so many links, and from that links you can download your software. And regarding the installation is very easy. Only the one part is difficult regarding the licensing, because we are using the correct version. So obviously the problems will appear. This is not a licensed version. So you can follow many YouTube videos for the licensing cracking, or you can also email me. I will help you out in the downloading. So this is the interface. This portion, the right-hand portion, gives you the latest news So CS, what enhancement has been made into existing software which are designed by ETABS. So there are different softwares in the ETABS library. As you can see, CS average, CS plant. So depending upon the nature of a structure, we choose the software accordingly, as I was saying in my earlier presentation. So if you are working for the plant design, so obviously you will go with the CSF plant. You cannot do the things in ETABS. So now let's begin. So to start a new model, we will click a new model. And yes, one more thing I want to tell you, system requirements. System requirements, whenever you buy a PC, so it should be, minimum should be Core i5 having 8 GB RAM. If SSD solid SSD drive is there, solid state drive, so it will improve the speed of your system. So you can easily design more than 30-story, 40-story. You can also do the dynamic analysis without any delay. Since I'm using i3, but the RAM is 16 GB, so it will just give delays in the analysis, but I can easily find up to design up to 14 to 20-story building. But for this case, since this is an introductory webinar, so I will keep the things as simple as I can. So this dialog box, whenever you click a new model, and I would recommend you just keep a copy and pen with you and try to write all the steps. So yes. Yes. So please mute your mic. Okay. So this basically, this dialog box, basically in this dialog box, you have to select in which system of units you will work, which code you will follow in order to design your structure. Organizers, can you mute this mic? Okay, so display units, I will just keep, if you want to keep the things as default, just select use saved user default settings. But if you want to change the system of units, just click here, whatever the system of units, or this dialog box is important to tell you because sometimes after you graduate, you are working in other part of the countries, even Dubai or Malaysia, Turkey. So everyone have got the different codes. I will show you from here. So units or steel section databases, we always follow the British codes or ACI codes. So I will just go standard. So you have to use IS 800. Italian codes are there. So I'm just keeping the things as default. The latest concrete design code is ACI 31814. So we will just select this one and click OK. So once you click OK, so this will give you another dialog box. And this dialog box is very important. And it is easy to use. Why it is very important? In this dialog box, you have to give the grid lines. And I showed you in my presentation that whenever you form this kind of a building plans, you have to convert this plan into the grid lines, center to center lines. So for example, okay, I have some AutoCAD drawings as well. So here you can see it is uniform grid spacing, number of grid lines in X direction, number of grid lines in Y direction, spacing of grids in X direction, spacing of grid in Y direction. But most of the case, the grids are not uniform in this case. So that's why I will show you the AutoCAD. Now this is the uniform grid plan. So you will see that the distance between each span is constant. One, so the distance is constant. So let me show you the dimension here. So it is 15 feet by 15 feet. So physically we can see this, it is a square, so I don't want to find the dimension over here. Now, what if the grid lines are not uniform? So for this, what we have to do, and look at this plan. So this is an irregular building. But at the start of your career, I would recommend that always go with the symmetry. Whatever the building you design, it should have must be symmetric in nature. Because if you provide more unsymmetry, so it will attract the lateral loads. It will attract the earthquake forces. If there is a symmetry, so the results will be easy to interpret and results will be easy to predict. Now look at this grid line plan. Let me show you the dimension. Now you can see that the dimension of grid 1 and grid 2 is 12 feet. And the dimension of between these two columns is 17 feet. So that means this is not uniform. So first, what we will try to do to keep the things easy, so we will try to work with a uniform spacing. And I will try to tell you at the end of the session how to export this kind of a plan in ETABS. In such cases, we don't have to define the grids. ETABS by default will consider. So in case of the advanced modeling, so what we do, we just convert this file into the DXF format, and we import this file in the ETABS software. In fact, in this case, the advanced modeling, you don't have to define the sections. ETABS will know that, for example, if this size of the column is, let me show you, dimension line. So the size of column is probably it will be 12 inches or 18 inches, 9 inches by 18 inches. So in advanced modeling, so you don't have to define the sections. So ETABS by default will understand that what type of sections you have given and your beam column layout. Now let's work with the uniform grid spacing. For uniform grid spacing, I will look at this, open this layout plan. The number of X, so X direction is this, Y direction is this. So along X direction, how many grid lines are there? 1, 2, 3, 4, and 5. And the spacing between these two grid lines is 15 feet. So what we do, number of grid lines in X direction are 5. And number of grid lines in Y direction are also 5. The spacing in grids in X direction is 15 feet, just right here. Okay, and another important thing I want to tell you. For example, if you have a data in meters and you are using the design in the feet, so what you will do, just write 5M. So M stands for meter. So when you write M, and here you will see the data is in feet, so ETABS by default will convert this value. So 5 meter, so it will give you the value in feet. But in our case, the data is in 50 feet, so I will just put 15 feet here. Put 15 feet here. Now look at story data. In the story dimension, you will see there are number of boxes. Number 1 is number of stories, typical story height, and bottom story height. In order to understand these 3 parameters, I would switch over the PowerPoint. Now look at this plan. So substructure, superstructure, structure beneath the ground, structure above the ground. So ETABS, what it does, it calculates the story from the base of the foundation. So whenever you put a story data in the ETABS, always put the story data from the base of the foundation. Normally we count our story from the ground floor, but whenever you design, it should be from the base of the foundation to plinth level. So that is the bottom story height. So base of the foundation. Now the question is how to decide the depth of the foundation. So this basically things you can find out from the geotechnical investigations, or you can also take some expert opinions from the practitioners who are working for a long time. But let me tell you, soil behavior is non-linear. So you cannot predict the behavior of soil. So always go for the testing. So the testing will tell you what type of foundation you have to use, at what depth you have to put your foundation. Now regarding our discussion, that bottom story height will be the distance from plinth level which is first ground level, plinth level to the base of the structures, that is the bottom story. And regardingly, now physically this building looks ground plus 1 story building, okay? But when you model this thing in the ETABS software, so this will be 3 story, 1 story, second story, and third story. So this thing is very important to understand. So for bottom story, what I'm keeping here, and in this software, you can also add some things. You don't have to, for example, normally we keep plinth height as 3.5 feet above from the ground level. Okay. I'm just keeping as 3 feet to 3.5 feet. And the base of the foundation is 5 feet below the ground level. So 5 plus 3, it will give you 8. 8 feet as a bottom story. Typical story height is 11 feet. You can also go with the 12 feet. Number of stories. So number of stories. So we are going to design a ground plus 4 story. So that is why. So we will have to give the 5 stories because 1 story will be as the bottom story. Okay. So in this way, you will give these kinds of instruction to the software at the start. After that, select grid only and click OK. So you have to wait for a minute. Now you can see the reference lines are created. So this window will tell you about the 3D view of the structure, and this will give you the plan. You can also work with, so let me give you the introduction to the interface over here. So from here you can see the interface is almost same in all the software. Even from the icons you can figure out. So this is for the save, this is for the undo, this is for the redo. Okay, this is for locking, this is for play, that means run the analysis. So majority of the icons you are familiar with. Either you have used PowerPoint, either you have used AutoCAD. So majority of the software, icons are predictable. For example, this is 3D, so I've just click this 3D, so it will transform our model in 3D. If I click plan, from plan you have to select the story, at what story you have to work. So story 1, click OK. From the elevation, now for elevation, see, try to understand the elevation. So this is grid line 1, grid line 2, grid line 3, grid line 4, grid line 5. In the y-axis, we have got x-axis, we have got A, B, C, D, and E. For example, if I want to see the elevation at grid A, so what I will do, go to the elevation, select A. Now what we will see, we will be looking in this direction, from this direction. Click OK. So this will give you the elevation from the grid A1, A2, A3, A4, A5. Similarly, you can also work with the different views. Now, when we have to switch the elevation modes, I will just let you know at the end of the session. First, switch it to the plan mode. If you follow my presentation, so I told you that first assign the grids. So we are done with the step 1. So let me mark it red. After assigning the grids, the second step is defining the materials. Since we are going to design an RCC building, so that means we have to give the concrete data and as well as the steel data. So for this, we have to go for the define. So you can also find out from this keyword define. When I say define, find out the define at the define, we have to define the material. So from here, for example, concrete having this or in a for foundation can you hear me, guys?
Yes, sir.
Okay,
Screen is not showing now. I don't
okay,
know.
it will be visible. It will be visible now. This part. We were discussing about the material property data. So in material property data, as I told you, you just give to the name the material. Since we are defining the concrete, so just give concrete, and 4000 PSI will give you the indication at first instance that we are using this grade of concrete. After that, leave the things as default. You can also change the color if you want, but these things are not important. And we know that RCC, the density of RCC concrete is 150. So I told you what you have to do, how the software will know that you are dealing with concrete wood. So you have to give this density, you have to give the modulus of elasticity, Poisson's ratio, coefficient of thermal expansion, shear modulus. So these things will define, these things will indicate the column, will instruct the column that you're going to work with this type of material. Now go to the modify show material property design data. Just verify whether here it is within 4000 or not. For example, if you are going to design 3000, so what we will do, just name the material 3000, modify show material data 3000 and click OK. Now the strength is 3000, but you have to change the modulus of elasticity accordingly. In order to change the modulus of elasticity, we all know that the relation between compressive strength and modulus of elasticity is 50,000, 57,000 is square root of FC dash. Okay, so now let me just a minute. So see, our compressive strength, for example, it is 3000. So I have already put the formula in this Excel sheet. It will give us the modulus of elasticity in pound per inch square. So similarly, if you are working with 2500, accordingly, the modulus of elasticity will be calculated, and you have to put this modulus of elasticity in the software. For this, I will just keep as 4000, which is defined by the ETABS software, and the modulus of elasticity is 3604997. If you compare it in the ETABS software, you will get the same modulus of elasticity. See, 3604996.5. So whatever we are being taught in our engineering courses and our classes, so the same things we are using in the software. So nothing is new. Okay, so again, I will change the data. To make it 4000, click OK, and make here concrete, and click OK. Now what we have done, we have designed the concrete. Now we will go for the steel data. Steel data 60 means 60 grade is steel, 50 means 50 grade is steel. So here it is written FY yield strength 50. So what we will do, we know that the is accordingly yield strength is 60,000 psi, ultimate strength is for 60 grade steel is 60,000 and ultimate is 90,000. Now look at this these two dialog box, expected yield strength and expected tensile strength. This has to do with the plastic analysis. Whenever you are going for the plastic analysis of your structural system, so in such cases what we will do, we will put this data, and this data is kept as 10% of this. So 60,000, the 10% of 60,000 is 6,000. So that is why you will see here it is written 66,000, here it is written 99,000. But for this case, we are just leaving these things because we are not going for the plastic analysis at this stage. So the important boxes are FY and FU, yield strength and ultimate strength. Click OK. Now we have successfully modeled our material properties. Now go back to the slides again. See how quickly we have done with the second step. Now the third step is define sections. Define section means, as I told you, we have to give the dimension to the sections, and obviously we have to assign the material as well. Section properties, since we are designing the frame sections, there are different kinds of sections in here. So for slab section, we will choose this box. For section, we will choose this box. For shear walls or walls, we will be selecting this tab. But since we are going to define the frame sections, frame matlab the beam and columns. So this box, frame. So already the built-in list is there. But what we will do, we will define our own. So click add new property. So when you add new properties, by default, the shape of sections are given to you. Mostly these are done dealt with the steel, concrete, special sections. That means, for example, if you are going to design L section concrete shape, because these things we are learning in our bachelor classes, T section, L sections, C sections. In case of concrete, so what to do, you have to use the special. Now here you can see the auto selection. If you remember a few moments before, I told you about, you can give all the dimension to the ETABS software, but this thing I will do in the functions. But for now, since our most of the structural components are rectangular in section, so we will go for beams. C is written as a suffix or a prefix, B and beam. It is 9 inch by 12 inches. Okay, so keep here 9 inch by 12 inches. Regardingly, the depth of beam is 12 inch. Width is 12. Depth width is 9 inches. After that, go to the modify, show modifiers. This is very important. What we do here, actually we modify the properties of a given section. Now why we modify the properties? We know that the concrete is weak in tension and strong in compression. Basically, when we put some coefficients here, the torsional constant, moment of inertia about 2x, moment of inertia about 3x. So what we do, whenever the load is applied on a concrete, so it will start cracking because it cannot take the tension. And we know appear in the concrete section, it will change the section properties. The dimension of the section will be changed. When the dimension of the section will change, its moment of inertia will change. When the moment of inertia will change, the bending resistance will change. So everything is interrelated with the section dimension of the sections. That is why what we do here, in case of beam, ACI code recommends these values. We design a beam section just to carry 35%. Okay, so that's why we put coefficient here 0.35. No torsional design. If you want to go for the torsion design, keep it as a 1, but mostly it is selected as 0.01, because if you go for the torsion design, it will increase your steel requirements. So these modifiers you have to use for the beams. Click OK. Now go to the modify show rebar. Here you have to select whether you are going to design column or beam. But we are going to design beam. Click this point. Now, if you want to give the cover, which is 1.5 inch, the minimum cover, top and bottom. And from here you will select the steel, whether you are going to select 60 grade steel or 50 grade steel. So different types of materials are already which material you are going to use for the beams. Click OK. Another important thing I would like to tell you that about, yes, now click OK. Now we will define the columns. Someone is asking about the modifiers. I will repeat the explanation when I will define the columns. So for columns, again, our column size is rectangular. Column size is, I'm just keeping a rectangle. So choose 18 by 18 inches column. But you will see the area is more than 108 inches square. So I told you, so whenever you use the size of column, area should not be less than 108 inches square. Or sometimes your structure will also pass a 9 inch by 9 inch column, but always more the better is recommended. Because structural engineering is not is a life-saving engineering. So for columns, what we have to do, go again same 18 inches by the 18 inches. So always go for the higher section that they start and size in order design the structures economically. For again, I will go to the modifiers. So for modifiers, what we are doing here, since we are just instructing the software, reduce the capacity by 70% or 35%. For beams, we are reducing the capacity of 35% because the codes are recommending 0.35 value. For columns, we will choose 0.70. Again, not designing for the torsion. Because the concrete is weak in tension, strong in compression, so when the load is applied, it will start appearing the cracks. So when the cracks appear, obviously all the load will be carried out by the steel. So that is why we are reducing the capacity of a section, of a concrete section at the start. Click OK. Because if you keep this 1, so the stiffness will be higher, it will affect the higher lateral loads. Okay. Again, go more. So here there are two things. One is reinforcement, one is reinforcement. So we always go for reinforcement to be designed, because if I give the command to the software and I ask the software to check, so what is the function of the software? Okay, so that's why we always go this checkbox, reinforcement to be designed. And for example, sometimes you are whenever you are working in a field, sometimes you are coming with such type of projects that you have to give a report what's the capacity of a structure. Because if a structure has experienced more than 2 to 3 earthquakes, and after that, in order to take more earthquakes, in such cases, what we do, we give this data, which is already there. We take out the structural, extract the data of the beams, columns, and reinforcement details, and what we do is and the reinforcement checks. Is voice clear? Organizer? So it is giving me the good connectivity signals over here, because when the message pops up that there is okay. Okay, and finally click OK. Hello. Yes. Now what we have done, we have defined a menu.
Sir, are you getting me, sir? Sir,
Choose
Sir
select section.
Rabinder? Sir,
So I will choose the built-in section and modify the property.
are you getting me, sir? Sir, your voice is not much clear. It's being interrupted again and again. I don't know, maybe might you have a connectivity issue or what?
Don't forget to save the model. So I am going to save the model first.
Are you getting me,
So
sir?
name is webinar.
सर आपकी वॉइस क्लियर नहीं आ रही.
Okay, wait for a minute. Let's see. Okay, now is voice clear?
Yes, sir.
Yes sir. Yes sir, voice is clear.
Okay, I'm getting multiple responses. Some are saying the voice is clear, some are saying the voice is now not clear. Okay, now it is better. The majority of students are saying the voice is clear. Okay. So now what we have done, we have modeled
सर स्लैब वाला दोबारा रिपीट कर दीजिएगा, वो वॉइस क्लियर नहीं आ रही थी इस वजह से. स्लैब वाली जो आपने स्लैब के लगाया था ना उसको रिपीट कर दीजिएगा प्लीज.
yes. Oh, okay. New slab, slab 6 is, so just write 6 in front of here, because in actual the different thickness of slabs are assigned in our structure depending upon the loads and the sizes. And choose the material property from here. These are different parameters. So normally we go with the shell thin. If you want to go for the one version, you will select the membrane, and because we know the ratio of in this what we do, we will assign the sections. The fourth step. In order to assign the sections, there are different ways to do it. There are different ways to do it in order to assign the section. Go to assign from here frame. Okay, you can also choose these icons in order to draw the beams, columns, okay, slabs. So this line, if you just put your cursor here, so it will pop up that this icon is for the beam drawing. Okay, this is quick draw tool for designing of the beam. Okay, this is quick draw tool for the column. So first we will try to put the columns in our building plan. So for column, just click this quick draw tool. So once you click this quick draw tool from here, you will select the property of the column. And we know that we define this column. Okay, so see 18 by 18 column is selected from this dialog box because our column is continued from the base till the roof level. So from here we put all stories and assign the columns. So as you can see, the column is placed over here. So this is the one way to place the column. But if you follow the architectural plan, you will see that, sorry, beam column layout plan, you will see that the column is placed at every intersection of beam column joint. So in order to place all the columns at one instance, so for example, for now I'm just closing this 3D view. So what we will do now, we will select the column, drag it like this, and it will, all the columns will be placed at one instance. Mode, so you will see that all the columns are placed. Once all the columns are placed, now what we have to do, we have to place the beams. And similarly, the beams are placed. Okay, some students are saying repeat this step. So I'm going to repeat this step. So Control Z. There is a quick draw tool. This icon is basically the quick draw tool for the columns. So select this, choose the property from here, from properties of the object. So as our column name is C 18 by 18, so what we will do, we will select the whole perimeter and it will assign all the columns automatically along these sections. You can also place your columns one by one. but it will waste your time. Similarly, for the beams, there are two ways to draw the beams. Now, first, I will tell you about a simple way of drawing the beams. So this is the beam. From here, you will select the property, and we assume the property of beam is 9 inches by 12 inches. One is select this point and rest your beam at the other column. Similarly, keep on doing these steps. Select one point and the point in order to complete the length of the beam. And another way, the quick way to draw the beam is, I'm going to delete these beams. Quick way to draw the beam is this icon, quick draw tool for beams. From here, select the beam size. Again, select the perimeter. If you want to see
Sir,
like in 3D,
sir, your voice is being again and again interrupted. Please maintain. I think so.
just
Sir, your voice is being again and again interrupted. I don't know. Maybe might have internet connection connectivity issue you have.
point method, automatic method, or quick draw tool. Should I rejoin? Because students are saying the voice.
Yes, sir, you can rejoin.
All right. The quick draw tool. So drag your rectangle and leave it corner. You must find all stories, otherwise
Sir, kindly rejoin the meeting.
to repeat the exercise. Pull the velocity.
Sir, please
Guys, please wait. Sir is joining us in just a minute.
Already selected all story. So whatever work we will do on the one story that will be replicated to all other stories. So I'm just selecting story 1, removing all the slabs. Why I'm removing? Because we are going to repeat this step. So see, with a single click, we have eliminated all the slabs from the roof. So this is the power of this all stories button. So go to the plan view. So till now, up till now, we are clear with how to define the beam sections, define the column sections, define the slab sections. And we know how to assign the columns and assign the beams with the conventional method and the quick draw method. Now go to the beams. So I slabs. So for slabs, I told you there are 3 options to form the slabs. Number 1 is point to point method. Point to point method may what's the difference? Once you select the point to point method, so from here you select the property and select this point, select this point, select this point, select this point, and finally select this point. So in this way you can also draw your slab. Now where to use point to point section, this icon, and where to use this rectangular icon? Sometimes your slab is always not rectangle. It has got a different shape, some curved shapes. Okay, it could be any shape, trapezoidal shape, triangular shapes. For example, if I want to assign a slab in a triangular shape, so point to point method, I have this point, select this point, and this point. So this is how we select the point to point icon in order to draw the different shapes. But since in our model all the slabs are in rectangular shape, so what we will do, either we will go for this draw rectangular floor or wall plan, or we will go for this quick draw floor plan. So again, let me remove these things. So for quick draw floor plan, what we will do, select this button, this icon. From here, select the property and select all the perimeter. So with a single click and within a short span of time, we have modeled all the slabs in our structure. So look at this 3D view. So you see all the slabs are placed at each story level. Now you will observe that at the bottom story, since we have selected all the story button from here, so at the bottom story at the foundation level, the slab is placed. But in actual, there is no slab at the foundation level. So what we will do, go to the plan menu, go to the base and click OK. From here, what we will do, now we will want to remove the slab from only one story. So we will choose one story. So select the slabs. Delete. Sometimes on plinth level also there are no slabs because plinth level पे slabs नहीं होते. There is just fillers are there, and after that the floor finishes are there. So we are going to remove the slabs from the plinth level as well. Now look at your model. So foundation, plinth level. So this is the first floor level, second floor level, third floor level, and fourth floor level. Save this model. Now go back to our PowerPoint. So we are done with the 4 sections. We have defined all the sections. We have assigned all the sections. Now what we have to do, we have to assign frame and shell loads. Now what's the difference between frame and shell loads? Frame loads matlab loads which are assigned on the frames. Frames matlab ye jaise beam hai. Consider this as a beam, okay? So this is frame. Shell matlab slab. Loads on the slab which are uniformly live loads or dead loads. So on the slab, dead loads, what could be the dead loads? Floor finishes, because we see that after when the slab is cast and we apply for the floor finishes, tiles, marble. So depending upon the type of finish you apply, you have to assign the load accordingly. Now, how to find that load? We have to refer to the code book. Now, what we will do now, go to the plan menu, story 4 or story 5, click OK. First, we are going to apply the dead load. For dead load, now we will go to the code book for C. We will be using this ASCE 716 because this design method we are following in our today's session. So for dead loads, we have to refer chapter C3, dead loads ASCE 716. So you will see different material types and correspondingly the loads are written here. In order to ease, I have just deliberately put this screenshot in the slide because from this page number, this page number is 426. From this page number, you directly go to the code book. So this is code book. Okay. I will ask organizers to email all the documents to you guys. So page number 426. There are two ways to find the required data. Number one is, in order to simplify, which I have done, remember the page or make a notes. Or Control F and write down here dead loads. Dead loads, the proper word should be floor finishes. Floor finishes. Okay, so when you click floor finishes, so you see directly we are at 426 page. So this is how we find out the data from the code book, because this code book consists of 889 pages. So it is impossible to read all the pages. So this is how we quickly find out the required data. Zoom it a bit and see if we are going, for example, we are going for the marble finishes. So marble and mortar or stone concrete fill, the dead load is 33 and the unit is PSF. So how to find the units? It will be written. Load is in PSF, pound per square foot. So this is the dead load. So what we will do now, I will use this data, marble mortar. Accordingly, you can also go with the cement finishes, whatever the finishes you want to apply. Organizers, is this meeting is recorded or not? Okay, okay. So marble 33. Now again we will go to the ETABS model. So there are two ways to select the slabs because we need to apply that load, shell loads on these slabs. Either you select the members one by one, or there is another way to do it. Sometimes we forget which property we have given to the slab. So in order to see the property, first we select it and right click from the keyboard. So it will give you section property is S6. So now what we will do, go to the assign menu. Sorry, go to the select. From here, choose the select, properties, slab sections, and choose S6. Click select. And close. And you will see all the slabs in our floor plan is selected, and you can also see the information from here. 64 shells selected. Okay, this is the quick way to select the shells. Or you can also go one by one. But don't forget to click this all stories. Otherwise, you need to apply the load 8 stories individually. So it will cost your time. It will not affect the analysis results, but it will cost your time. Now all the slabs are selected. Now in order to assign the loads, now there is a keyword. See, since we are assigning the load, so what we will do in ETABS, we will find out the assign button in the title bar. Go to the assign menu. Since this is the shell load, matlab the load is on the slabs. So go to the shell loads, uniformly distributed load. From here choose dead, because we just saw from the code book marble is under the dead load category. So choose 33 here, the value we saw from the code book. Let me show you it again. So this is 33 here, and click OK. So see, the load is applied. The 33 is written in all the slabs. Similarly, what we have to do, we have to search for the live loads. Let's go back to the PowerPoint, see in what page number I have written the live loads. So for live loads, we have to refer to the chapter 4 and the table is 4.1. So go back to the code book again. Just write the live loads here. Chapter 4C. Okay, click on next several times and you will be yeah, just a minute. You need to click the next several times in order to find the table. We see another way. Okay, office building. Office building. Yes. So you have to try several keywords in order to find out the value. So in this table, you will see, so different, for different occupancy means different nature of building, we have got different loads. So for apartments, here it is said C residential. So now we have to find for this residential system. So residential system is at the bottom of this table. C residential. So for residential,
Sir, can you share these notes after the session?
Sure. I will share this code book and the presentation. So for residential building, you can see here, for 1 and 2 family dwellings, we have to use 10 pound per feet square, PSF. And the value written in bracket is in kilonewton per meter square. But since we are working in US customary units, so pounds per feet square, we will be using this value. So all other areas except staircase, because for the staircase, you have to calculate the load of steps manually. So always the live load for the residential building is chosen 40 pound per feet square. Whether you are using the Indian codes or you are using the uniform building codes, in both the codes, you will see the live load value is written as 40. Now and similarly, if you are going to design any manufacturing plant, libraries, hotels, office buildings, so accordingly, see the load is written. For the offices, it is 50, lobbies, corridors, it is 100, because you will see the lot of movement in the corridors. So that is why live load provision is high. Okay, but for our case, since we are going to design consider this is a residential building. So what we will do now, again, we will go to the select menu, select, and after that, what we will do, go to the properties again, slab section, and our slab was S6, select and click close, and again you will see 64 shells are selected. Similarly, how will you assign the loads? Go to the assign menu, shell loads, uniform loads, and from here, since we are going to apply the live loads, so just select live here. And just we saw from the code book that is 40 pound per feet square for the residential building. Click OK. Now we are done with assigning the dead load and live load. Now we will apply the frame line loads. In order to apply the frame loads means the load of walls on the beams. So what we are doing now, we are categorizing the exterior walls and interior walls. So the exterior walls will lie on this exterior beams and interior walls will lie on these interior beams. So I'm just assuming that the exterior wall thickness is 9 inches and interior wall thickness is 6 inches. Okay. So for 9 inches, what we will do now select the all stories from here. Okay, select the frames one by one. Because in actual plan, in actual architectural plan, exterior walls are more thicker than the interior walls. And in RCC frame structures, the walls, the function of wall is to support, it gives the partitions, it divides the room. It is not a structural component, it just acts as a partition. Yes, it provides the stability between these two columns, but the main function of the wall is to provide the partitions. Now you can see, just select the 3D view, all the exterior frames are selected. What we will do now, go to the assign menu. Now frame load, since we are applying the frame loads, so we have to select frame loads. The load is distributed, we are not applying the point load. So when we have to apply the point load, abhi main aapko thoda bata. First let me complete with this distributed load. So distributed load main wall is our dead load. Now we have to calculate the load of the wall. In our engineering classes, we know how to calculate the load. In order to calculate the load, what we have to do, we have to multiply volume with density. Now, how will we find the value of density? So it will be from the material which we are using. Whether we are using bricks, concrete, hollow concrete blocks, so every material has got different densities. So for example, if we are using the CC blocks, so cement concrete blocks has a density of 145 pound per foot cube. But now we have to put the units in kip per foot cube. So just divide it with 1,000. So it will give you 0.145. Multiply by, okay, now multiply by with the height and thickness. The thickness of exterior wall is 9 inches. So 9 inches का मतलब क्या हो जाएगा? That is 7 feet. So 0.75 feet. So 0.75 feet multiply, and now we have to give the height of the wall. We know that our story height is 11. Our story height is 11 feet, and the depth of beam we have kept 12 feet. So 12 inches, that means 1/5. So 11 minus 1, that is 10. So our wall height is 10 feet. Just click enter. So it will give you the wall load 1.0875. Okay. So click OK. So you see the load is applied on the exterior walls, and the similar kind of problems on the beams we do in the classes. Go to the plan menu. Now select the interior walls. So those who are still in third year or final year of their session, I will recommend them try to get command on the theories and the formulas which we study in our classes. Though they are the boring, but they will give you the feel. They will give you the confidence on the calculations which you are going to perform. Now all the interior walls are selected. So let's see whether it is being selected for the all floors. So yes. So now go to the assign menu, shell loads, frame loads distributed. Again, we have to choose the dead load category. Now don't confuse with this dialog box. This is for the trapezoidal loading. If you remember, we have done many kinds of problem in our classes, in our bachelor studies. Trapezoidal loads, the combination of triangular and rectangular loads. So now similarly, what we have to use the density of material multiply by, now the thickness will be 0.5 because the interior wall is of 6 inches, multiply by the height, which is 10 feet. So now the interior load is 0.725. Click OK. Now the frame loads and shell loads are applied. So we are done with the gravity loading. Now what we have to do, we have to apply the seismic loadings. So for seismic load, first we have to define the load patterns. Load pattern का मतलब ये है कि what types of loads are going to act in our structure. So dead load or live loads though we have assigned. Now in order to define the load patterns, we will go to the define menu, select the load patterns from here. Just to try to remember this thing whenever you are going to define anything. So it will be in the define menu tab, defining piers, diaphragms, grooves, section cuts. When you want to draw anything, so it will be in the draw menu. When you want to assign anything, assign means assigning the loads, assigning the joints, assigning the rigid frames. So this will be in this tab. So just remember these things. So that is why I did not waste my time by explaining each tab, because it becomes makes the session boring. So that's why I started my session with the basic icons which we mostly use. Now for load patterns, go to the define menu, load pattern. Now here you see the dead and live loads are already assigned. So one का मतलब ये है कि ETABS by default will consider the self weight of structure. Self weight का मतलब the load of beam and column. So that's why it is self weight multiplier 1. So for live load it is 0. So that means we have assigned live load. So we are not commanding the ETABS to calculate it by yourself. So that is why self weight multiplier is 0. For dead load it is 1. Okay. Sometimes you might see all the frame loads, all the dead loads which are assigned by us. So what we assign in different category, which is known as super dead. Super dead. So from here you select super dead. So super dead means all the dead load which are assigned by us. So it differentiates between what actually the dead load is only of the frame structure and what is a dead load which we have externally applied. But for this case, I have just considered every load in this pattern. Now for seismic loads, we know that the seismic loads, earthquake in X direction and earthquake in Y direction. So short form what we write, earthquake in X direction. From type, we will select seismic. From auto lateral load, so these are the codes. So I told you Pakistan building codes and uniform building codes are compatible to each other. And Pakistan, you will not find any tab for the Pakistan building code. So we will be selecting UBC 97. Okay, if you are working in other countries, so accordingly you will choose your design codes. Euro codes are there, New Zealand codes are there, American codes are there. Okay, Indian codes are there. So accordingly you will choose. So EQX, similarly, earthquake in Y directions, all the values will be same, only we will change the name, click add. After defining this EQX and EQY, what we will do, we will select this modify lateral load. Modify lateral load, just click it. So it will bring you to this dialog box. So since we are going to apply the earthquake in X direction, so what we will do, we will uncheck all the other parameters in Y direction. And now we are not dealing with the centricity, okay? So that is why I have unchecked these parameters. If you want to keep it on, so it is not a big deal. Okay, so just let this box checked. Now seismic coefficients. In order to find the seismic coefficients, again we have to refer to the code books. So the sole purpose of this session was to make you aware with how to fill the data from the code books, because it's not about just operating the software, how the software is functioning, how the values are being input in the software. Okay, so soil profile. So soil profile will be determined from the geotechnical investigation. So let me show you what I have. So there are, see, 6 categories of the soil profile. So SA denotes the hard rock, SB is for the rock, SC is very dense soil and the soft rock, SD is stiff soil profile, SE is soft soil profile. So this data basically will give you, will be got from the geotechnical investigation. For our case, since I'm just assuming we are going to design the building for this Hyderabad region. So Hyderabad region, first we have to see in which seismic zone the Hyderabad lies. So for this, I have to refer to this seismic zoning map of Pakistan. So the color diagram is written here, is given here. So from here, you see the Hyderabad is located in the province in. Okay, so it is in the blue range. So blue range, that means zone 2A. So similarly, someone is living in Chitral. So you see Chitral is in red color. It is high seismic zone. So for Z, it is zone 4. So accordingly, using this seismic zoning map, you will find out in which zone we are living. So let's consider for the Hyderabad region, zone 2A. Now we know what's the zone 2A. Accordingly, we have to define the factor, zone factor. So depending upon the zone, there are different factors given. The value of Z. Okay, so for 2A, the factor is 0.15. Now go back to the ETABS. So I'm just assuming that soil profile is SC and zone factor we just saw from this table for Hyderabad region, the zone factor is 0.15. So what we will do now here, we will just select 0.15 and it will automatically select the other values C, A and CV. Basically, they are the seismic coefficients. These are the related with the estimated ground acceleration. You will be able to understand this concept more when at least you have learned introductory subjects regarding the earthquake engineering. Importance factor. Now this thing is clear to us. Soil profile will be given to us from the geotechnical investigation. Zone factor, I just told you how to read the values of the zone factor. You can also find these factors from the building codes. Now this is building code of Pakistan. Okay. The building code of Pakistan. You just go a little lower down the pages, you will find out the zoning map. Yes. Now seismic hazard. These are the seismic zones. So Pakistan is divided into these 5 zones: 1, 2A, 2B, 3, and 4. Accordingly, the peak ground acceleration is given. Now see. So for each province and cities, the seismic zone is given to us. See, if someone is from Balochistan who is attending this session, so he can find out his region and accordingly he will find out the zone. Similarly, for Punjab region, you will see if somebody is living in Attak, so accordingly the seismic zone is found. So the chart I've taken from this code book, seismic zone. And if you just lower down certain pages, so you see the similar table which I showed you in the slides, it is table 4.1. And in this way, you can, in this code book, you can also find the relevant data. For example, just write hard rock. So it will take time because the document is not properly loaded. Just write the keywords here and you will be able to find the relevant data. Lower down a bit. The simplest code to use for the seismic coefficient, UBC and Indian standards. Rest of the codes are difficult to understand because they require a lot of parameters. Okay. So now for importance factor. So important factors means that how important your structure is. Because schools are more important. In school buildings, we have to take care of the life safety of students. Similarly, hospitals are most important structures. And any international heritage sites are most important structures. Okay, so similarly, what we have to do, we have to give the importance factor to our structure. So how this importance factor is found out from the codes. So let me show you the, yes, essential facilities. Okay, to understand this, first I will explain you this slide. So building based on its occupancy, it's classified into number of groups. So group B buildings mean the business related buildings. That includes the banks, insurance agencies, government buildings, police stations, or fire stations, or doctors' offices. Group E buildings are educational buildings. Okay. Group F buildings that are termed as high hazard. Examples: factories and dry cleaners. Group H fireworks, which deals with the chemical industries. Institutional group I. Okay. Similarly, residential group is group R, places providing accommodation for overnight stay. This may houses, apartment buildings, hotels and motels. Storage tanks, for example, warehouses, sorry, not tanks, storage buildings. जिसमें warehouses आते हैं, parking garages are there. And miscellaneous or group U building. Group U buildings means which includes the water towers, barns and towers. So based on the occupancies, the buildings are classified. So if I talk about the group I building, I just say I'm going to design a group I building, so it will directly refer to the institutional building. Similarly, group R building will refer to the residential building. ठीक है? And similarly, mercantile group M जिसमें departmental stores या हमारे जो you might see ये grocery stores या जिसको हम supermart कहते हैं. Gas stations are also there in mercantile group. So what we will do, depending upon the occupancy category, we will find out the importance factor. You will see group 1 division. Now here it is also written which type of group buildings are also there. So group H is there, group I is there. So accordingly, you can figure out what this group I means. So every detail is written in this slide. Since we are going to design our design for the residential building, so number 4 is standard occupancy structure. All structures housing occupancies or having functions not listed in category 1, 2 and 3 and group U occupancies. That means residential building. So for that case, we have to go for importance factor 1. So come to the ETABS, select 1 here. In time period, I'm asking ETABS to calculate the time by itself. Never go for the user defined time period. You'll find the equation how to calculate the time period. But whenever you calculate the time period by yourself, you will not consider the stiffness of the building. But whenever the ETABS will calculate the time period, it will calculate the stiffness of the building. So you won't be able to get the same answer whether you find out the time by yourself or program calculated. So recommended is go with the program calculated. So story range. So earthquake will hit from base story to the story 5. Since the base story is buried in the ground, so it will be actually hit from the story 1. But फर्क नहीं पड़ता ज़्यादा इससे base. Now over strength factor. This is very important to understand. Basically, this parameter will decide whether your earthquake building is earthquake resistant building or earthquake proof building. So when you keep this over strength factor 1, that means you are instructing the program, I want a building which is earthquake proof. Nothing will happen to my building when earthquake hits or when earthquake is experienced by my structure. But this will make the structure highly uneconomical. Why highly uneconomical? Because you will provide higher sections and more steel, okay, in order to over strengthen your structure. So we have to go to the building codes in order to see this value. For example, if I select 3, that means I'm reducing the earthquake load 1/3. Agar if the earthquake load is 1000, for example, so 3 means, so only the 1/3 of the load will act to the structure. So that is why mostly the structure you will see, they deform, but they do not fail. Most of the structure in low seismic zone. Minor damages are appeared on that structure, but they do not fail. Now let's see how to see the value from the code books. Now, again, go to the Pakistan building code. So see, from UBC code, you will also find the gravity loading data, the live load data. For a school, it is 40. Yes. So this table 5.13, first we have to define structural system. So we know that we are our building structural system is RCC frame structure. So in building frame system, what we have to do, so moment resisting frame system. So we have to select concrete. We are not designing for the special moment resisting frame. Special and ordinary, the difference is only for the reinforcement. So, because special mean the building will have the more reinforcement. So that is why you will see the over strength factor is high. So for ordinary moment resisting frame, so we will just select this one, point number 4 for the concrete structure, and the value of R is 3.5. So this value will be put in this box 3.5. Click OK. And the same data we will put in the Y direction. Now we will uncheck all the parameters in X direction. We will keep on the parameters in Y direction. Use the same data. Zone factor was 0.15 and this was 3.5. Click OK. Now seismic loads we have assigned. ETABS by default will also define ETABS by default will assign the seismic load in our structure. But if you are using the Start Pro, you have to assign the seismic load by yourself at each joint. So the Start Pro is more manual approach. ETABS is. That's why I told you that ETABS is more user friendly than other softwares that we use in our building. Now our wind load, what we have to do, again go to the load patterns, wind X, choose wind, again choose UBC 97. Similarly in wind Y, UBC 97, modify lateral loads. So there are two ways to apply the wind load. This is automatic method, the exposure from extent of diaphragms, but we will go for the manual method, which is exposure from the shale objects. So what we do in this method, we will assign the walls. हम wall draw करेंगे, but it will not have any weight because we have already applied the weight of the walls on this beams. So it will be the null walls and wind speed depending upon the area. So I don't have the document which describes the speed of wind in the UBC 90 in Pakistan building code. So for example, just assume 47 is high wind speed for the Jamshoro Hyderabad region, and exposure type B importance factor is 1, and click OK. Do the same here for Y direction as well. So now what we will do, we have assigned the dead loads, seismic loads. Go back to the PowerPoint. So this is done. Frame loads are also done. Seismic loads are also done. Define load combination, the 7 tables load combination. So for load combination, what we will do, since it is defined, so we will go to the define menu, go to the load combinations. Now either you define the load combinations manually, see it from the code books, just write load combinations. Depending upon the load patterns, so it will give you different load combinations. I just give you the simple example. You might have studied the RCC design in your undergrad. Or 1.2 of dead load plus 1.4 of the live load or 1.6 of live load. Basically, this actual you will designing it will not change in actual because poor workmanship is there. If you are designing a structure which is expected to carry 3000 psi, but due to poor workmanship, you see this, the assembly will not be there, which you are expecting. Again वॉइस का इशू आ रहा है क्या?
Yes, sir.
So load combinations. Okay, let me search it from the ACI code. Wait a minute, let's see. There is one direct way to all generate all the load combination, but I just wanted to make you aware from the code book how the load combination values are derived. It is mostly the start of the page. Okay, anyways, we are not wasting the time. You will just put several clicks here because you will see it is showing you the 240 searches. So put the several clicks, so it will bring you to that page. But in ETABS, what you have to do, you don't have to put effort manually. You just click this add default design combos. So when you click this add default design combos, it will pop up a dialog box. So this dialog box will ask you which structural frame system you are dealing with. So since we are going to design for the concrete frame design, so click OK. So automatically it will generate the different load combination. It will be around 18 load combinations. So let's see what is inside these load combinations. So I'm just selecting that load combination 1. So select modify show. So here you can see it is 1.4. Similarly, combination 2 is about 1.2, the combination of dead load and live load with a scale factor which is given here. Similarly, combination 3 is dead load, live load and wind load in X direction. The scale factor is 1.2. So these all values are taken from the codes. At the start of this model, so we have already given the code information. We are using ACI 31814. So that's why these all values are taken from this 31814. You see this code book. So you will find out from the code books, we will just have to keep put the several clicks. But since we've already ran out of time, so I will try to finish the session. So see, for combination 5 is 1.2 live load wind wise. So similarly, 18 load combination depends because we have defined the 6 load pattern. So accordingly, the combinations are generated. If you eliminate the wind forces, so the combinations will be up to 11. Okay, so click OK. After defining the load combination, so what we have to do, okay, I just would add another step, fix the joints, because mostly we forget to do this, fix the joint, because our base is fixed in the ground and this icon basically represents the simply supported. pin joint. See, this is pin joint. So what we have to do, we have to make this joint fixed. Now, why to make this joint fixed? Because in actual our foundation is fixed. When you put a fixed design, so it will give you 6 reaction components. When if we talk about the 3D, 6 reaction components kaun se hote hain? We know that 3 are rotational and 3 are translation. But when you make it pin, so it will give you only 3 force components, and rest of the moments will be taken by the columns. So in order to depict the actual conditions of what we will do, we will try to make it fixed. So for fix, what we will do, go to the plan mode, select best, click OK. Okay, so all joints are selected. What we have to do, we have to only apply this for the one story. I don't know whether the option is not visible for the one story. Let me see. I think I have to rerun the system. Just wait a minute. I will rerun the software. Just I closed the 3D view, but it was also not visible in the plan view. In cracked version, you will come across these kinds of problem, but not a big deal. So now see, now this option is visible to us. Go to the base. So select one story from here. So in this case, it is already selected. Select these joints. Go to assign menu. Since now what we are doing, we are assigning the joints fixity. So we will go to this tab, click joint, restraints, now fixed. So 3 translation and 3 rotational, all will be fixed. Click OK. So it in the 3D view, now see the icon is changed. So this will depict the fixed joint. So now all the loads are applied. Now what we will do, we will analyze the building. Ninth step is we will analyze the building. So in order to analyze the building, simple, either you go from the analyze and select run analysis, or press F5 from the keyboard, or you can also select play button. Select play button here. Just wait for a minute. It will take a few seconds in order to analyze the model. So you will see the deflected shape. Okay, now we want to see whether our model is working fine or not. Switch to the plan mode. I think in this case all beams will fail because I think we have applied the higher loads. Let's see, go to the elevation. Click OK. Now you will see this. This is the deformed shape of the structure. Now, how to verify whether our model is working fine or not? So what we will do now, this is show deformed shape. From the keyboard, you can also click F6. Okay, from this case, we have defined the 6 load patterns: dead load, live load, earthquake in X, earthquake in Y, wind X, wind in Y. Acha, we have not applied the wind X and wind Y. We have just assigned it. Anyways, no issue. So dead load, where we know that the building should deform downward. forces which are generated due to the external force. So two are shear, one is major, one is minor, one is major moment, one is minor moment. Okay, so axial force diagram and torsion. So you might have studied in your course of strength of materials. So we always go with the major moment, which is 3, and shear 2. These two parameters are our requirement. So select moment 3, click apply. So you see this is your bending moment, and go to the elevation view. And we know that this is the behavior of fixed support. So we are getting the negative bending moment at the support. Just a minute. You see, we are getting the negative moment at the supports, the hogging moment. So this is how our structure should behave. Okay, you can also see with the other load patterns, EQX. Click OK. Let me show you 3D. EQX. So moment is behaving linearly. Yes, EQX, and similarly EQY. I think there is a problem. Is EQY. EQY is giving us the correct behavior. See EQY. The load is behaving linearly. So this is what should have reflected in the analysis. For EQX, I don't know why we are getting the smaller values. So let me see whether the load data is defined correctly or not. For this, I have to unlock the model anyways. So this is how we analyze it. Let me show you the Excel diagram. So from Excel diagram, it will be clear to us. Just a minute. So this icon, select Excel and click apply, then OK. So this is due to the EQX. Now this is under tension, this is under compression. So that means the earthquake force in X direction is creating tension in this columns and compression in this column, and the two columns in between are experiencing no any loadings. You can see it from here, just elevation mode. Just a minute. So you see all the compression along A grid line or tension. One, C, tension and compression. So no forces are in between the columns. This is what the behavior should be. Now, in order to design what we will go, this is for the design. Select design combinations. So by default, all the combinations which we have defined are on the right hand side of this box. Click OK and start your design. Start design check. So see, the building is designed, it is showing the green color. So that means the capacity ratio, okay, it's fine. Show me the percentage. So in order to see the percentage, what we will see, go to the display design info. whether it is the economical design or not. From here, we will select the rebar percentage. Click OK. You will see the columns are having 2.08% and the beams are having 0.40%. So that means according to ASCE code, the the reinforcement in column should be in the range of 1 to 8%. Okay. So that is why you can see we are within the limits, but the design is also economical, because when the reinforcement is more than 3.5%, because steel is the most expensive section in our structure. So it is our responsibility as a civil engineer, we have to design the structure safe and economical. So what if agar yahan par 5 hota, so what we have done, we have changed the size of this column. Now let's see on the other elevations. So mostly we will be getting the similar values because our plan was symmetrical. So that is why you will see the values in the columns are same, and only the values in the beams are varying with the minor difference. Okay. So what if, let me just give you the quick demo about the modification factor. Go to the define menu, load pattern. Okay, what if I just put 1 here? So with this, I will end my session. Just take 5 more minutes. So 1, again analyze the building. This icon is for the design. So yeah, again the building is not failing. Anyways, that means the section size and the columns is sufficient to carry the load. And since our building is not located in high seismic regions, that is why we are getting all window fast. Okay, for detailing, after designing the section, so what we have to do, we have to run for the detailing. I will just quickly cover this detailing option because it requires another lecture to understand the detailing option in a detail. So detailing is here. You won't find this option in ETABS 2018 version. For this, you have to download CSI detailing software. So just concrete frame design, detailing, start detailing. So I just went to the detailing option and you just click start detailing. So it will automatically generates all the sheets which are required by a civil engineer. You see, this is a floor beam framing plan. So all the number of beams, title of beams, we don't have to do anything. In order, if you want to export this drawing into the AutoCAD, what you have to do, just export view. Okay, drawing exchange format or choose AutoCAD 2018, start export. It will take some time, but you will be able to see all these files in AutoCAD software. And accordingly, if you want to do some editings, you can do there. Okay, unable to complete export option, you may try again or use.
Please again repeat the last procedure, how to export in AutoCAD first.
Okay, so in order to export first, what you have to do, you have to detail. In order to run the detailing tab is on the top. So just click the detailing option. I'm not going for the detailing preferences. Just keep it as default. In this, what you have to do, you have to just quickly tell you these are the units and detailing concrete component preferences for beam. For example, for beam, what you have to do, CB columns, walls. Okay. Rebar selection rules for beams. So here you have to select the number of bars. The spot should be the smallest number of bars that should be in your component. What should be the maximum largest number of bar and preferred size of the bar. So your beam is divided into different zones. The end zones, okay, and the mid region. I have to explain you once this detailing is complete. From here, I will explain how the zones are divided. So in order to export, what you have to do, just right click to it and click export view. From here, choose drawing extent format and start export. So let me save it in another directory. I think the AutoCAD software is open, that's why it is unable to export. You have to close the file. I have covered this topic in detail on my YouTube channel and YouTube video. You can also take a reference from there. I have made a separate tutorial for the detailing work. Sure, sure. I will share the link. Just wait for a minute. Okay, I will paste the link on the chat box. Okay, ready. The file is ready, so it is saved in desktop. So let me show you. Go to the AutoCAD. From file, open, drawing. I've saved this drawing in a desktop. So it is floor framing plan. Click open. So you see, the framing plan is with us. So you don't have to do an extra effort. This is the power of software. That's why we go and use the software. So every dimension is written. The location of beam and column is written. Similarly, you can also see the different drawings. For example, the beam section A. Section B, that means the smaller. These are the general sections in order to just let you know that how the drawings are made in this detailing plan. This is how the concrete typical view is. It is divided into the zones. So tie zone is zone B. The zone at the joints near to the joint is zone A. Okay, this is how it is divided into the number of zones. So as I told you, I've covered this topic in detail on my video. It will take around 30 to 40 minutes to explain you this. Similarly, now the most important thing in this software, reinforcement cage views. If you want to see how the reinforcement is placed along the beams, see, you can also see the reinforcement. This is how we have to put the reinforcement in our structure. For those just like who are entry level engineers, they want to see, because every time you cannot go and go to the site to see how the cage is formed. So this software helps you in this feature as well. Similarly, for the columns, you can also see the cage view. Since we have only assigned the one section, So that is why we have got CC1. So this is how your column section will look like. You see all the stirrups, the lap length, everything is shown here. So from the foundation to your top story level, everything is shown here. The drawing sheets, general notes are there. Okay, one more thing I would like to tell you, that concrete beams, schedules and tables. For concrete beams, we always go for with this schedules. This is 6CB1. Okay, the name of B is 6CB1, divided into number 4 steps.
Sir Rabinder, sorry to
Yes.
interrupt you, but the meeting has been scheduled till 6 p.m. So automatically the meeting will be closed. So sir, kindly, it is a request to you, it is a humble request to you to kindly wind up the meeting, as we have just left with 20 minutes, last 20 minutes, sir.
Okay, just give me 5 minutes. I will try to finish this session.
Because we have to continue with the question answer sessions as well, sir. So kindly wind up the meeting.
Okay. Okay.
Thank you, sir. Thank you so much.
So this is how we do the detailing. So all the rebar plan is shown to you. So it will also tell you in zone A how many numbers of bars and which size type of bar you have to use. Okay. So if you want to export this file as well, you can right click and click export. And similarly choose the location and just click start export, and you can see all these details in the AutoCAD software as we have done in this for framing plan. So this is all about today's webinar. So if you guys have any question, you can ask. I know this was detailed. Most of the things will be understandable to you when you practice it by yourself. But since it is recorded, if you want to follow any step, you can see the recordings, or you can also see the videos on my YouTube channel, because I have explained everything in detail and precisely. So if you guys have any question related to today's session, you can ask.
Sir, please share the link of your YouTube channel.
Okay, just a minute. So it's
Also, sir, please share your also presentation or PowerPoint which you have shown to
okay.
us.
I will
because we need.
put all the things in a drive. I will put all the things. So this is my video, ETABS in 2 hours. So where I have given the complete training. So channel name is Instruct Guru. Just write Instruct Guru here. So on this channel, you will see I have worked out with the different types of drawing. What if you are working with the egg-shaped structure? Because whenever you work in a field, you will come across very innovative concepts. So how to model such a structure. For example, if you are designing a roof, steel roof truss, because in markets, warehouses, we see the steel roof trusses are there. So regarding the detailing video, so detailing in ETABS is there. So this is video is only dedicated to detailing. If those who want to learn the software from to end, so in these lockdown days, I have tried to make these all videos in just to benefit those students who are not able to afford the trainings, because in the universities, or if you go for the private trainings, they are costing around 12,000 to 15,000. So that is why the minimum fees was charged for the today's session, just to make you realize you don't take these things for granted. Okay, because if this session was a free, then you might have left. But since it was paid, so that's why majority of the students are with us till now. And after the so much interruption of the internet, you didn't lose your interest. So that is really remarkable. Yes.
Sir, please share your slides and also the material, because we need your because you said that we did not find the Pakistan and UL. We used the U70 as UL. We cannot
UPS.
find the UPS 70.
Ji. Okay, I will upload all these documents. I will upload all these documents on a drive link. So organizer, I will share this drive link to the Kamran, who has organized this
Sir,
event. So
you
Kamran,
can
it is your responsibility. Yes,
so
please.
you can Sir, you can also upload the files on this WOOP as well in
So
the
how to do it?
chat box.
So do we have a time, because I am running out of battery.
Okay, sir, no problem.
So
Okay,
don't
no,
worry about the
sir.
documents. Don't worry about the documents. You can also contact me on my Facebook. You just write down my email if you want. So email is also written on my videos. So just a minute if you want my email ID.
Sir, can you write it in the chat box? Your email.
Yes, जी, बिल्कुल. Chat box is.
Hello, sir. I have a question.
Yes, please.
सर हम डिटेल्स की स्ट्रक्चर एनालिसिस करते हैं या डिजाइन करते हैं उसमें हम कितना पैसा कर देते हैं स्पेशली जब हम एक क्रैक वर्जन यूज कर रहे हैं तो अगर मैं कमर्शियली यूज कर किसी कंसल्टेंसी या किसी फर्म में यूज कर रहा हूँ ईटेप को डिजाइन करने के लिए तो उसके रिजल्ट्स और एनालिसिस या डिजाइन पे मैं कितना रिलाई करता हूँ
नहीं, आप क्रैक वर्जन की बात कर रहे हैं. Can you repeat your question? Can you repeat your question?
मैं कह रहा था कि जब हम ईटेप का क्रैक वर्जन यूज कर रहे हैं ऐसा नहीं है तो वो हम ईटेप के रिजल्ट्स पर कितना कर सकते हैं कि ठीक है भाई ये रिजल्ट ठीक है हम इस पे एग्जीक्यूट कर सकते हैं या कंसल्टेंसी में या किसी फॉर्म में यूज कर रहे हैं या फिर कमर्शियल यूज कर रहे हैं डिजाइन के लिए तो कितना हम जो डिजाइन का है इसका रिजल्ट है उस पर रिलाई कर सकते हैं.
सर का आई थिंक नेट इशू हो गया दोबारा.
सर्वे
साथ भाई काइंडली यार मोबाइल डेड हो रहा है, मैं लीव कर सकता हूँ मीटिंग? सर का नेट इशू हो गया.
जी ठीक है, सेशन वाइंड अप हो गया. जिसके क्वेश्चंस हैं वो लोग रुक जाएं भले. बाकी जो लीव करना चाहता है दे कैन लीव. रेस्ट ऑफ द things will be provided to you, the recording of the meeting as well as the files and the documents. जो फिर उनसे रेफरेंस लेना चाहता है या प्रैक्टिस करना चाहता है they can continue. Thank you so much for joining the Thank you so much for joining the meeting. Thank you to each and every participant. Thank you for taking part in. And inshallah soon the certificates would be provided to you via email. किसी किस्म की भी query या कोई भी question हो तो you can email us at ascquestchapter@gmail.com and you can also contact me personally. Thank you so much for joining. Take care.
Session close to you. लीव करे सकूंगा.
I said कि अगर किसी को कोई भी किसी किस्म की query या question है सर रविंदर से तो they can wait here or else you can leave the session because the session has been ended. There is some connectivity issue with Sir Rabinder. He will be joining, I think. If any one of you have question, you can wait.
सर से कांटेक्ट हुआ है मेरा, वो बोल रहे हैं कि मैं 5 मिनट में ज्वाइन करूंगा. सो जिस को भी क्वेश्चंस हैं वो मीटिंग में ही रहें. बाकी दूसरे मेंबर्स जिनको कोई भी क्वेश्चन नहीं वो लीव कर सकते हैं. Guys, if anyone has any question, kindly ask. Otherwise, we will end the meeting.
Guys, check out your chat section. The email has been dropped by Sir Rabinder Kumar. You can ask him any sort. If you guys have any sort of queries, you can contact him on Facebook as well. I think he has some connection problem, and the documents and slides will be emailed to Kamran or Amanla, me, and we will be giving you. Thank you for bearing with us, and sorry for the connection problem. And the certificates will be provided to you. Thank you. Take care. Allah Hafiz.
Thank you, sir. Allah Hafiz.
Thank you so much, sir, for your precious time.
Thank you, sir, for having us. Thank you so much, sir. It was a great session.